Hey everyone, and welcome to SQL Bits. I really wish I could have made it across the water over to London for you guys this year, but unfortunately, as we know, we're kind of all stuck here virtually. But thanks for taking the time to join me. I'm Monica Rathbun. I'm a consultant with Denny Cherry and Associates, and I've been doing SQL Server for about 20 years now. Don't pay attention to my age. I'm not that old, but I've been around for SQL Server for quite a long time. This session right now is Always Encrypted. It's going to be a very much beginner session, a 101, introducing you to what Always Encrypted is, some key terminology you're going to use, how to set it up. We're going to walk through a demo and see how we can get this to work really easily. But one of the big things you need to pay attention to with this session is about the gotchas, the things that will stop you from using Always Encrypted inside your environment. There's several different things that you might run into that can really create a roadblock as you're setting this up within your environment. So you just want to make sure as you're diving into Always Encrypted and as we walk through this, really figure out if Always Encrypted is something you can use your environment or not. There's lots of different encryption options out there for you. We'll talk about a few of those. But for right now, again, this is a 101 session for Always Encrypted. And thanks a lot for joining me. Let's dive into it. As I said, I'm Monica Rathbun. I'm a Microsoft MVP. You can reach me during this session. I'll be live here for chats, which is great. I think that's a fantastic option Bits is actually giving us. So at any point in time during this, if you have questions, feel free to put it in the chat windows. After this, if you want to follow up with me, I'm on Twitter at SQL Espresso. I do have a blog, sqlespresso.com. And of course, you can hit me up at LinkedIn if that's what you want to do. I'm here to answer any questions that you might have. So a little bit about the agenda of what we're going to walk through. We're going to go over the terminology. We're going to talk about what it is and how it works. We're going to go over those key gotchas that I mentioned just a second ago. We're going to talk about keys and how those play a role, and there's different types of keys that have to do with Always Encryption. And then we're going to talk about a really cool thing called secure enclaves. It allows us to get past a few of those gotchas, but that's with SQL Server 2019 and above. So we're holding that to the end. And then we're going to talk about how you can use it in your environment. And if time allows, we're going to dive into those demos and set it up. This is only a 50-minute session, so let's cross our fingers that we get to that part. I know I talk pretty fast, so hopefully that will help us gain some time and allow us to get to those demos before we're done. So basic terminology. First of all, it's important for you to understand what encryption is. Basically, it's just converting readable data into an encoded version of data that kind of hides it from view. It lets it so you have to have a key in order to decipher that information and reveal the actual contents to the application or to the user or to the DBA or whoever's actually trying to engulf that information. Just basic terminology that you have to know about. Encryption is all about encrypting, which is hiding the data from plain view, and decrypting, which is uncoding the data so you can actually see what your result set is. All of that is using what's called a certificate, which digitally signs that security object, and it contains the public and sometimes private key information from SQL Server. You can actually generate these certificates outside of SQL Server or within SQL Server. As we walk through the wizard, we're going to see that we can create them in there as well. And then we have keys. Keys are what's going to unlock and lock and protect that data. We're going to dive into that pretty significantly, and we can see how we can set those up inside SQL Server, where they're stored, and what exactly it does. We're going to have a key, and then we're going to have a key that protects that key. So we'll see how that works. And then we have to store those keys somewhere. And those are the vaults. We have several different kind of key stores that we're going to walk into and check out. And we'll see how easy that is to set up. So first, let's look at a couple types of encryption that we already know about as DBAs. We've got TDE. It's a familiar one to all of us. Transparent data encryption. It's done at the database level, and this is called data at rest. It's decrypted while it's in motion from memory and to the storage processor, right? So it's only encrypted while it's sitting there. Anytime the data is in motion, there's a possibility of being able to get to that data in an unencrypted fashion. So you have to keep that in mind when choosing this option. Then you have column level encryption. Column level is inside SQL Server. The database administrator can clearly see the data. SQL Server knows the keys. It's all internal. And then that's column level as opposed to database level, which was TDE. Then we have this thing called dynamic data masking. And really, this isn't encryption at all. It just kind of masks the data. Like Social Security number, when you see like the first 3 digits of the Social Security number and then everything else is stars behind it, that's an example of data masking. And that just actually prevents the view of the data. It's not really encrypting the data for anybody. So that's not what we like to call encryption. Management seems to like that one because they feel safe and secure that nobody can read things such as their salary up on the screen, but it's really not encryption. And then we have this brand new thing that just brings us above and beyond what TDE did. It's a column level, not database level, but it's encrypted everywhere. It's encrypted at rest. It's encrypted in motion. It's encrypted to the database administrator if you want. You have several levels of protection that you can put inside the system that prevents users, even the administrators, from getting to that data. So we'll talk about that as we move on because that's what you're here for. So let's see what it is and how it works. Now, it was created and brought to us in SQL Server 2016 SP1, and you actually had it available to you in the standard edition. There was no code changes required in order to use it, which is fantastic. Me as a lazy DBA, I don't want to change any code for implementing any kind of feature that I want. So that's very, very significant. And you can block DBAs. A lot of people, again, we're going to talk about managers, right? No managers want you to know what they make, how much money they make. But us as a DBA, we have access to the full database. We can get to things. Always Encrypted gives us that secondary layer where the database administrator can't get to the data. We see it encrypted as well. So as we go through and set this up, I'll show you how that works. It's encrypted when it's sent to the application, and it's decrypted using those keys and brought back for the application layer to decipher it. Using the .NET drivers and any other Always Encrypted drivers that are out there. Again, we're going to see this as we move along. This is really great too when a customer wants to hire a vendor, an external vendor, and they want them to administrate their database, but they still want to protect that data. Using Always Encrypted allows us to do that. The other ones, TDE and the other encryptions prior, didn't allow us to do that. So there's really a very good use case for this. So it's something definitely I would be checking out if I was looking to protect my data and using a third-party vendor or someone else like a consultant myself has access to your database and you still want to protect the data from them. There are 2 types of Always Encrypted options available to you. And these are important because this makes a complete difference on how you can actually query this data and how protected the data is on whether you can truly decipher this if you kind of paid attention to patterns or not, or if we've made it one step harder by randomizing the data, which we'll talk about. So deterministic is the pattern type. It allows us to be able to use where clauses against the data. And so let's say we had a person's name, Monica, my name, and that was encrypted. You would always see Monica encrypted as ABC, ABC, ABC every single time the Monica text was created. That also works for being able to search against that and index against that, because Monica would be able to be searchable because the engine would know what the pattern is. And that's important when we're actually trying to performance tune something that's actually encrypted, right? That makes a difference. The pattern matching is important, but it also makes it a little less secure because, again, if you know the patterns, you could figure out the data. It's still encrypted, which is important to keep in mind. Now, the next part is randomized. This is where it's more secure, but guess what? It's not searchable, right? So when you're doing your where clauses, you can't search it because there's no pattern matching. So it's important to actually to keep that in mind. It's very secure. It's great for securing things like things that have less values to it, like birthdays or like social security numbers, things that have a smaller amount of data. Maybe it is, I can't think of it right now, but if it's got a smaller group of data set, randomized is probably a good thing. When it has a larger data set, deterministic is probably the best because there's lots of different values out there. Pattern matching would be less obvious. But if you had, oh, here's a good example. So let's say for some reason you need to encrypt gender. I don't know why, but say you need to encrypt gender. If you always encrypted with deterministic, it would be extremely easy to figure out who is male, female, non-binary, all of that, because there is not a ton of values available. In that case, using randomize, I wouldn't be able to figure out what the gender was because it's going to give me a completely different randomized encrypted value for both of those. So female would always be something different and I wouldn't be able to figure out the data. So hopefully that kind of gives you a clearer picture of how it works. And the two options that are going to be playing a part in this. Now, remember, the most important thing here is in deterministic, you can do where clauses, group bys, joins, and indexing. With randomize, you can't. Okay, so that makes a big difference. Knowing your data load, knowing how you're using the data plays a huge part when you choose between these. And as you set it up, you have to choose which option you're going to do based on the column level. So think of this ahead of time on how that data is used. All right, let's look and see exactly how this works. It's pretty simple. Here's a graphic provided by Microsoft, and it's going to walk us through just a quick query in how this all works and how important the actual driver, a supported always encrypted driver, in this case a .NET 4.6 driver, plays the role. It's very simple. The application is going to send a query. And in this case, we're looking at getting the patient name using a social security number. And you'll notice it's provided in plain text to the driver itself. The driver has the master key information. The master key is going to be needed to unlock the column encryption key. And don't worry about those keys right now because we're going to talk about them a little more in depth in a few minutes. But the query is sent to plain text through the actual driver, and it talks to the database. The database is going to query the information and actually return the data encrypted still when it's doing all of its processing. It's not until that column encryption key is opened with the master key that the data gets converted in the driver. And then it actually will return the results set to the application. So it's really the driver that's making a huge difference. Everything in the database is going to stay encrypted, and it's going to rely on that master key and that column encryption key to unlock that data and present it in plain text to the application. We'll walk through all of these terms to clear some up, any questions that you may have. So just hang tight with me as we go through what this terminology is and what these keys actually do. But I said earlier, anytime you're looking at always encrypted, you need to look at the roadblocks that prevent you from using always encrypted. Because the data is encrypted, again, we can't always do some where clauses on it. We can't do likes. We can't use partitions. Aggregations would be very difficult when it comes to encrypted data. All of the data is in an encrypted fashion, so you cannot do things like computed columns. You can't have restraints, check restraints, and things like that on the data because it's encrypted. It doesn't know what the real data is. There's no distributed queries, so there's no linked servers that can be used with always encrypted. No triggers, no identity columns. You cannot index columns on randomized encryption, the data encryption type that we talked about earlier. There's only certain data types that are available to do that. Microsoft gives us really great documentation on this, so you can go and look at their docs to see all of the gotchas, but I want you to look at these main ones because a lot of these here are the ones that create roadblocks and actually stop us from using always encrypted. Now let's talk about those keys. There's only 2 keys we need to worry about when it comes to Always Encrypted. And we're going to go into each one of these to give you a better example of what they are. Column encryption key is your number 1. We'll get into some details in a minute. And then that key is encrypted with what's called a master key. And if you remember from that example, you know and see how it's used later in the process to unlock that column encryption information. Now, let's talk about column encryption key. Now, this is your main key. This is the key that you put on a per column basis. You can use 1 key per column and make it really secure, or you can set up 1 column encryption key and apply that same key to each column you want to encrypt. It's actually what's encrypting the content itself. It's only decrypted using the master key. And then the metadata regarding this key is going to be stored in the database. It is the only thing that's stored in the database. The key itself is not stored in there. It's going to be stored out in a key store that we'll talk about later. Only the metadata is actually stored there, which gives us an advantage over TDE as well and makes things a little more secure. Then we have the column master key. This is the key that encrypts the key, right? The column master key is what's going to unlock and talk to the column encryption key. It protects that. It's stored in a trusted key store, and the database, again, only contains the metadata of the column master key. So it gives it the location of where the key store is, how to find it. It doesn't actually store the key itself. And you can look for that information in one of the system views. It's column master keys. So if you want to peek in there yourself, you can find out the information. It doesn't give you the keys, so you can't unencrypt anything, but it shows you where this stuff is stored. Now let's talk about how we're storing the keys. A really basic one, which most people actually use. It's not my favorite, but it's what most people actually use because it's actually local to your server, and it must be deployed on any server that's going to be reading the Always Encrypted information. It's called a Windows certificate store. We'll walk through that as part of our demo. But I just want to let you know that it's available on all of the machines. It's going to be needed on every server. When you do this certificate, it'll have to be on every server that you choose to run Always Encrypted on, as far as the application server, in order to decrypt the information. Then we're going to have the Azure Key Vault. The Azure Key Vault is really my favorite. It allows a layer that gives your security administrator access to the Key Vault, and they can lock it down even from people like me, the database administrator. It's a great place to store passwords. It's a great place to store the actual keys for your Always Encrypted, and it's easy to set up. Very, very simple, and you can set it up as part of the process when we walk through the wizard. But it does require a reliable internet in order to actually encrypt and decrypt and get those keys. So if the internet is down, you're not getting to your data because it can't actually decipher it and give you the unencrypted values. So that's something important. Nowadays, all of us are living in the cloud. Internet is usually not an option, not a downfall for us. There's so many redundancies, and it's a rarity to actually have the issue where the internet is not available and you can't get to your keys. But it's something definitely to keep in mind when you start storing things in the cloud. But to me, it's safer. They create backups for you. It's reliable. And it's a one fits all, right? You don't have to manage it per server. It's out in the cloud. It will reach out there, get the information it needs, bring it back down regardless of what server you're on. So to me, it's definitely the option to look at, and we'll look at here a little bit more detail. So here's an example of the certificate store where it actually is on my local computer. And we're actually creating and storing it in the certificate of the current user or on the computer itself. This one I created through the wizard, and it just shows you here there's an Always Encrypted certificate sitting here that it will go out and use. And then again, the key store list on each machine that's hosting the application. That's kind of really key on when you set this up and choose this. If you don't have that set up and you don't have the proper permissions, you could run into some issues. So here's the Azure Key Vault, and it's pretty complex, but look at this. It can actually be set up with your server administrator. It can be set up with your systems administrator. It can be set up with the security officer. It can be audited. You can see every single time your Key Vault is accessed, so you can create a great auditor report when they want to know what is actually getting to your key and using that key to decrypt your data. Again, it's very, very easy. It's a click of a button on how to set this up, and we'll see it when we go through our demo if we get to that and time allows. So there's this thing called Secure Enclaves. Secure Enclaves was actually introduced in 2019. And it actually doesn't work for everybody because it is hardware reliant. You must be on a certain supported hardware in order to do this. But it gets rid of the problems that we have with some of the comparisons that we do, our likes and our pattern matching and sorting, and some of the gotchas that are inside Always Encrypted, because the values are randomized and it can't actually look for pattern matching for randomized. The Enclave for Always Encrypted helps with that, because when it actually sends the information to the database, it can go into a protective part of memory that's trusted as an enclave, and it can unencrypt the data to do the query processing and then re-encrypt those results back to your driver and let it unencrypt it again. So if we remember how this worked, the driver is what actually unencrypts all of the data and makes sure it has the proper keys and all of that. So SQL Server is sending encrypted data. And when it's processing encrypted data. So it can't do your pattern matching and your likes and stuff like that on randomized data. The Enclave, because it's a secure part inside your memory, it can actually read it in plain text there. So when it's query processing, it can do a normal like statement, a sort, a where, a wildcard, all of those types of things inside in plain text, like it normally would for unencrypted data, and then do what it needs to do and kick it back out as encrypted still to where the driver has to decrypt again. But this is a special part of memory on this particular hardware. So there is a lot of things you need to read about secure enclaves if you're looking to go this method, and you really need that pattern matching and things like that occur with inside SQL Server. So definitely check those out. It is a SQL Server 2019 and above option. So those of us who are using Always Encrypted from 2016 SP1 forward, until we reach up to 2019, we don't have this option to us, and we still have all those gotchas that we have to get around. So again, the Secure Enclave gives us the option to do the pattern matching, right? Your where clauses, your having clauses, the group by stuff, your range comparisons between this date and that date, or between this range of numbers and that range of numbers. All of those things aren't able to be done without using either deterministic or the Secure Enclave. Sorting. Who would have thought sorting is going to stop me, right? It has to know what that data is in order to put it in the right sort option or the right sort order. So if you're using randomized, you can't sort, because when it's encrypted, it doesn't know what the values truly are to properly sort it. Your Secure Enclave, because it's reading in that plain text in that part of memory, can sort the data properly, kick it back out, still encrypted in the proper sort order, back to the driver that will decrypt it. So there's also a trace flag that you can do in order to turn these on once you have the Secure Enclave done. It's this trace on 127-1. You'll have to turn that on to allow these rich computations to happen inside the Secure Enclave if you're using it. So let's talk about using Always Encrypted. We'll walk through a few screenshots so you can become familiar with what some of the things look like and some options you have to check. And then we'll move forward to our demo here in just a few minutes. So here's where we're looking in SSMS 18.0 or higher. I think we're on 18.5 now, so that's probably not an option, not a worry for you if you keep up with your SSMS. You can look under security and you'll see where your key information is stored here. Again, it's metadata information, not the actual keys itself. Those are stored in your key stores, which we talked about. So you can see we've got our master key listed, and we have our column key here. And then if we're using if we're using the secured enclave, then we actually have to checkbox this here, which was to allow rich computations to happen. And that means we're using the secure enclave. It's going to actually know that there will be some some rich computations, which we turned on with that flag before in prior versions. Here, there's a checkbox that you don't have to use the flag. It actually will do that with the checkbox and turn those on. This is when you're setting up your key, your master key, it has to know that exists. So here again, SSMS is going to use that driver. Remember, we said it had to have a supported driver. And in this example, it's the 4.6. Here, when we're connecting to our database, you'll notice now there's an Always Encrypted tab. And then you actually will have enabled Always Encrypted. It gives you the URL for your key store information if you're using secure enclaves, and some more information here in the properties when you actually connect to the database. It also allows us to have our connection string here. Our connection string is what you're going to also use when you're putting it in your application. And when you put in your connection string, you're going to have this column encryption setting enabled. And you're also going to have this in SSMS, because SSMS is the application when you're querying stuff, that's the application querying it. So let's say you had a web application. That's one application where you would put this connection string. But SSMS, if I'm querying the data myself, that's the application that's going to be querying the data. And it needs to know that that column of your encryption setting is enabled as well. So make sure when you're doing Always Encrypted, as we run through the demo, that you do have this connection parameter here in your setup before you connect to the database. So there's a few permissions you have to have in order to decrypt the data in the application or as a user. You're going to have to view any master key data information. It's the definition. View any column master key definition. It's just the metadata permission. And then you're going to have that same permission view any column encryption key there. Those are needed in order to get the information from the database on all that information on what columns are encrypted, where the key store is. All of that information is here. And if you look, when you're actually creating an application and you're doing your application connection string, it has the same thing that we saw in the SSMS window. The column encryption setting equal to enabled. You have to have that in order for it to know that it's going to have to get that key information in order to decrypt that data. So let's go and walk through a demo. Okay, so diving into our demo, let's look at my MRDEL server, which happens to be a 2019 instance. But remember, you're allowed to do SQL Server 2016 SP1 and above, and these standard edition will allow you to do this. But because I've practiced this, I'm going to go to my connection properties first. I'm going to go to options, and I'm going to go here to my Always Encrypted and make sure I'm currently not enabled. And I'm going to check my connection parameters and make sure these are empty. We want to start off with a fresh, clean slate. So I'm going to connect, and we're going to be using my AdventureWorks 2017 sample database. And you can download this from Microsoft on GitHub if you don't have it already. But we're going to right click, and we are actually going to use the employee table for this. If you right click on that and go to encrypt columns, we're going to walk through the wizard and see how this all works. So if I hit next, you're going to notice it lists out all of my columns. But note the state. State has a little warning sign. Remember all the gotchas we talked about? Constraints and triggers and identity columns and lots of different things within particular data types that aren't allowed inside Always Encrypted. So for these columns, you'll get a warning. This one has a data type that can't be encrypted. This one has some default constraints. That has default constraints. So it kind of gives you a little heads up right in the beginning for you not to proceed. In this case, we're actually going to use birth date. And if I click on that, it notes that it's not configured right now. We need to configure it. Here, we're going to do our encryption type. And remember, these were deterministic or randomized. It's important to know, examine your workload and how you plan on querying this data before you choose this option. In this case, we're going to do deterministic. And here we need to choose our encryption key. This is our column encryption key. We can use one key for all of the columns we choose to encrypt on this table, or we can do a different column encryption key for every single column if we want to be more secure. In this case, we're actually going to create a new encryption key. If there were multiples here, we would have a drop down that we could choose from. But in this case, it's a brand new one. It's our very first one. If we had one that we had already created before, it would give us an option to choose an already created encryption key for this table. But we're going to choose new, and we're going to hit next. And then we're going to go and it's going to say, let's use a master key. We need to have a master key. It's what protects our column key, if you remember. So we're going to auto-generate a key. Again, if I had a different master key already created, it would be in this drop-down for me and allowed to reuse. Then it's going to ask where we're going to store these keys. Are we doing it in a certificate store? Remember, if I do it in the certificate store, that actually has to be on every application server that's going to be querying this table in this particular field. And then we have the Azure Key Vault. If I click on this, it'll require me to actually authenticate for Azure. And prior to that, I would have had to actually set up an Azure Key Vault inside Azure itself. It's really simple. It's a quick walkthrough inside Azure. You create a vault, and if I had a vault associated with my actual Microsoft Azure sign-on, I would be able to click here in the drop-down and see that vault for me. So it makes it really easy for me to incorporate the Azure Key Vault for this setup, and it's a piece of cake. It's my preferred method because once it's in the Key Vault, it can be available for all of my databases and tables that I'm encrypted. But for this instance, because it's just a demo, we're going to use my Windows certificate store local to my machine here. And I'm going to hit next. And then here is pretty cool. If I actually want to save all of this setup and use it on multiple servers, I can actually have it generate a PowerShell script, and I can run that script to enable all of this, or I can use that same script to put it across my entire environment. But here I'm going to hit proceed to finish. It's very, very simple. It's going to run through everything here. It'll tell me my server name, my database name, what I named my master key, and where it's being stored. And then it gives the name of my column encryption key. Remember, CMK is master key, CEK is column encryption key. And then it gives me information about what column I'm actually doing. It's the birthday on the employee table, and I've chosen for it to actually be deterministic. And then I'm going to hit finish. Now this takes a little while to actually set up, but in the process, I'll just go ahead and kind of fast forward so you can see the results. Hey, look at this. And I did this on purpose. I wanted to show you what happens when you don't make sure you don't have any constraints or any gotchas associated with your table. Now the birthday did not give us a warning. However, I still failed, so it didn't pick up this for me. When I click on failed, it'll tell you why I failed. Here, there's a constraint. There's an actual check constraint against the birth date. So it won't allow me to encrypt this field. So we're going to cheat. I'm going to hit OK. And I have to close this. It won't allow me to go back and restart again. I'm going to close this, and I'm going to go and alter my table. And I'm just going to go ahead and drop the check constraint just so we can do this, and the demo gods will play nicely with us. Oh no, it says it's not a constraint. Let me see. Now I'm just going to go ahead and drop this constraint so the demo gods will play nicely for us for the rest of the demo. So let's go ahead and do that, and it's just going to drop. And what I have to do is start again. So back on the table, I'm going to go back, and we're going to run through this pretty quickly. We already went through here. Again, I don't have anything. I'm going to go and choose deterministic, but look, we already created an encryption key before in the prior run through, so that encryption key is already there, but I can choose to create a new one if I wanted to. That's what I was kind of talking about when we first ran through. So I'm going to keep the one that we have just so this goes faster. Because I already created a master key, it's going to allow me to skip it and use the master key that I already created earlier. So we hit next and we're going to run, and this time we're going to finish without problems, and then we're going to be able to see how this works. Okay, so that went pretty fast. We get a success and it says pass, so I'm going to go ahead and hit close. Now let's query our table. We are on AdventureWorks 2017 and hit employee. I want to actually go and look at that birth date column. Look at that. Birth date is now encrypted. It was really simple. Now all of my data is encrypted. Nobody can see anybody's birthday. It was very, very simple. Now, how do I undo that? Well, in order for me to actually see the data in an unencrypted fashion, I've got to change my connection. And we're going to go here onto my Mr. Dell again, and we're going to go to connection properties. And I need to tell it in the options that I'm using Always Encrypted. This is my application that's going to be accessing the data. Usually, this is a web app or some kind of user app in which we would add that connection string information and tell it that the encryption is enabled. SSMS is going to play that role for me as a DBA here so I can see the data. We're going to use Always Encrypted, and we're going to checkbox this. And if we had a secure enclave, this would be the information regarding the secure enclave. The additional part here is I got to go to the connection properties, and we've got to put in that connect statement. And I should have copied it ahead of time. Let me grab the connect statement here, and we're going to do this again, demo gods. Go to connect. I'm going back to options. We've already checkboxed this, but we need to put it back because I hit cancel. And then we're going to go to the connection properties, and I'm just going to do this column encryption setting equal to enable. Remember, that's the same thing you would put in your string for your application. And then I'm going to hit connect. Now, because I've already had this connected with my prior settings, I need to actually create a new query that will get the newest connection settings. And we are actually going to, I will copy this over. We're just going to select and see if the data is unencrypted now. And we want to make sure we are on the right database, and we're going to run it. And there you go, birth date. We've got that completely exposed now, and it was just a matter of changing the connection string within inside my connect of my query here. Now remember, we have the ability to block DBAs from being able to do this. It's all about permissions on that user. So I happen to have full access to my, my instance here, so I'm able to do that. But it's very simple. You can go back and forth and unencrypt this. If I want to go back and do the connect, and then I can just redo it. I uncheck this, I take this out, hit connect. I'm going to go back to a new query window. We're going to select this again, and I'm on my 2017. When I do that, what did I do? Why do I still have it? I'm going to go back to my connection properties. Let's just double check. That's out, but let's do this. Let's actually disconnect, and we're going to connect again, making sure my options are not there. Hit OK. I'm starting that up again. Let's copy this into a brand new connection and paste. There we go, birth date. I wanted to show you that because a lot of times you're going to be showing this to management and things like that. Just keep in mind you want to establish a new connection, a new query window, just to make sure you've got the right things showing, and you're not going to go round and round and round digging yourself in a hole thinking you've made some kind of problem or made some kind of issue that you have to rectify. Just remember, connect, disconnect, and start again. So as you can see, it's really, really easy to set up encryption for your column within inside your database, and it is again on a database level and a table level. So I want to show you one more thing. I want you to be able to look and see that you can prove easily that you actually have encryption set and what those encryption information is. You can look this up in sys columns and sys tables here for your birth date column for employee table. And you can see right here it says what algorithm it is, what encryption type it is, and it's deterministic. I have here a couple references for you. MSDN has some great information. It's the Microsoft Docs. If you're going to dive into Always Encrypted at all, I highly, did I say highly? Highly recommend you read through these documentations so you can see all the limitations that it needs, whatever hardware requirements that you may have with secure enclaves. I have a link for that here. TDE, if you want to compare what TDE is, remember that was transparent data encryption. If you want to compare what that option is to Always Encrypted and determine which one is better, I give you a link for that. And Aaron Bertrand has a fantastic blog on Always Encrypted and the limitations that exist in it. I recommend you read all 4 of these before you embark on Always Encrypted yourself in your environment. Thanks again for joining me virtually. I hope you got something, at least a foundation level about Always Encrypted for your environment throughout this presentation. I really wish we were on site. I would love to be able to talk to all of you guys in person about Always Encrypted and talk about what you guys plan to do inside your environment. But until then, you can reach me at SQLespresso.com, on Twitter. I'll do my best to answer all of the questions that we have during the session live in this Q&A, and then follow up with any of those that I didn't get a chance to ahead of time. But until then, again, on Twitter, my blog, SQLespresso.com, LinkedIn, and you can always email me. I'll be happy to chat with you about it and answer any questions. But thanks again. I truly appreciate you taking time out of your day in your home office to join me and watch this. And enjoy the rest of the conference. And we'll see you around. As soon as I can get across the pond and COVID goes away for all of us, I will see you and make my trip across the water. So thanks again for having me, and we'll see you soon.